my gosh, I'm not even ready.
That's
Alright, you know what? I'm not even gonna go for you. Just throw it up. That's not a good idea.
So, our last topic for the year will be statistics and probability. A very basic introduction, all right? We're not going full force into a lot of the more complex things, but this will give you a good overview because a lot of you will probably end up taking some type of a statistics-based mathematics course in the future. And if not, even beyond that, a general knowledge and understanding of statistics is really, really important as you are all about to be, hopefully, functional adults, okay? Lord willing, you will have jobs and you will be making money and you will be, scary enough, voting one day. Making decisions that affect not only you, but your family and your friends and your neighbors and the country as a whole. And with that responsibility comes the need to understand all the information that is being thrown at you. Okay? You will be getting information from people trying to sell you stuff and people trying to buy your favor or earn your favor and get your votes, all right, or change your opinion. And being able to take that information in and synthesize it is a really, really important tool that unfortunately too many people are lacking, and that's how we end up with a bunch of terrible presidents. Okay? Election cycle after election cycle after election cycle. Just terrible president. Okay? So, you see statistics every day. All right? Every day you see it, whether you recognize it or not, in your day-to-day life. Things most common you may see on news or advertisements or, scrolling, whatever. Things like 7 in 10 Americans believe that the arts unify communities, and 2 in 5 Americans have changed an opinion or perception based on an arts experience. That is a statistic. Notably, 21% of 8 to 11-year-olds have a social media profile. That is a statistic. Okay? It's information about a group. Kind of what it boils down to. All right? And so we have some definitions here, some key terms to make sure you understand. All right? Starting with statistic is the science of collecting. That's that first part. Collecting, organizing, and then the most important part is analyzing and interpreting data, usually to make decisions. It doesn't have to be to make decisions. Sometimes we just want to know. Okay? But most of the time, we are interpreting and we are analyzing that information in order to make a decision. So then, we've got data. Okay? What is data? Data is just information. Information coming from observations, counts, measurements, or responses. It could be something that we see and we observe. It could be something that some people tell us. It could be stuff that we count. It could be stuff that we measure. A census is a collection of data from every member of the population. So once every 10 years, the United States collects a census in where they attempt to, fairly successfully, but not 100%, to get information from every single person that lives in the United States. That is a monumental task. That is a monumental task when you are looking at millions of households, hundreds of millions of households, trying to gain information from every single one of them, all right, in a short time span, is monumental. It's huge, which is why it doesn't happen very often, okay? But a census is a collection of data from every member of a population. Well, population can vary, okay? A population is of an area of interest. So a collection of the outcomes, responses, measurements, or counts for an area of interest. So a population could be the entire United States. Okay? Or, if I didn't care about the whole United States, I just cared about the town of Montford, then my population would be the town of Montford. Every single person in the town of Montford. For every single student in the 12th grade. A population is a collection of all the responses. Now, because getting a census is often too daunting of a task to do, please don't come in late and be disruptive while I'm talking. While a census is nearly impossible to do on a regular basis, we can't get a collection of everything from the population. We take a sample, which is a subset or a part of a population. So it would take me too long to ask every senior, what their favorite, lunch was this year. It'd be much easier if I took a small portion and asked maybe 10% of the seniors what their favorite lunch was this year. And that would be a sample, a subset of the seniors. And I would hope that that sample is representative. And that's a very important thing in statistics, and we'll cover more of it later, is representative. You want it to represent the population. You want its views or opinions or the counts or the measures of the sample to be similar to and represent that of the entire population. So we want to go ahead and look at a couple different things, and we want to make sure that we can identify the difference between the population and the sample. A lot of times when we're looking at population, we're looking at all of that area of interest. And then sample is the part that's actually being surveyed or counted or measured. So we look at this first example. In a survey of 410 human resource professionals, 148 of them said that a job candidate was disqualified because of information found on social media. Okay, so looking at that, what do we think our population is going to be, that area of interest?
410 human resource professionals.
Not quite. Just human resource professionals. All of them. There's probably more than 410 human resource professionals. Probably a lot more than that. Most companies have at least one. Bigger companies have more. So our population will consist of all human resource professionals. Now, we can't ask all human resource professionals. That would take way too long, and half of them probably won't answer our emails. So we take a sample. What's our sample? The 410 that responded, that were surveyed. And that's that important part. The sample is the part that was surveyed or counted or measured. Population is everything. The sample is the part that was measured. In a survey of 751 employees in the United States were asked how stressed they feel at work. Of the 751 respondents, 616 said they feel at least a little stressed at work. Identify the population and the sample. Describe the sample data. So what is our population? Employees in the United States. And we need to be very specific about that. We can't just say all employees, because there's employees all over the world, and this specifies the United States. So our population is all employees in the United States. And then what is our sample? The 751 that were surveyed. Okay, and so I forgot to leave a spot for it, but we want to describe the sample data. And we want to describe the sample data, and that's just saying, okay, what is the statistics telling us? Okay, so describing the sample data is simply this part right here. Of the 751 respondents, 616 said they feel at least a little stressed at work. That is the sample data. A lot of times with the sample data, you'll get a percentage, okay? But sometimes it's part out of a whole, all right? Yes, ma'am.
So do we have to put, like, for the population, we have to put all of them?
Yes, I would be specific, include all of whatever group is. So when we're describing the sample data, we're just looking at what is the statistic? What is the statistic that is being told? So that we surveyed 751 employees. Of them, 616 said they feel at least a little stressed out. That is our sample. That is how we describe the sample data set. In a survey of 1,516 teens in the United States, 1,228 said mental health is a significant issue for young people in the United States. What is our population?
All teens in the U.S.
Specifically in the United States. Not all teens in the world. It may or may not apply to all teens in the world. But that's not where we drew our sample from. We drew our sample from all teens in the United States. And our sample is going to be 1,516 teens surveyed. And we want to describe the sample data set. Okay? Of the 1,516 teens, 1,228 said that mental health is a significant issue for young people. That is our description of the sample data. What was that outcome, the result? What is that statistic that's being measured? Okay, so population versus sample. Now, when we're looking at information that's gathered from data, we have two different things that we can have. We can have what's called a parameter or a statistic. Okay? A parameter is a numerical description of a population. Usually can only be gained if we have a census. If we know everything, we have response from every part of that population, we get a parameter. More often or not, we can't achieve that goal. So we have a statistic, which is a numerical description of the sample characteristic. Okay? So, for example, a parameter. Okay? It would be fairly easy for us, and the business office could do it, or the admin office could do it, for us to get the average GPA of a Montverde Academy student. We've got all the records, easy Excel spreadsheet, we could do that pretty simply. So we could do a census of Montverde Academy GPA. So that percentage, if our average GPA was, whatever, 3.9, that would be a parameter because it includes every single Montverde Academy student. We have that information. We have that as a census. The parameter would be we have an average GPA of 3.9. Okay? We can do that. We can achieve that. But if I wanted to get the average GPA of all American students, getting all of that information would be very, very difficult. And so we would take a sample and we would get a survey and we'd say that the average GPA of an American student is probably low, unfortunately. Let's be generous and say 3.1. And that would be a statistic because it's based off of a sample. I can't get all students in America's GPA. So I took a sample and I'm going to get a statistic. Okay? So we want to think very, very carefully about what information is gained. Do we have the information on the entire population or do we just have a sample? And that will determine whether or not it's a parameter or a statistic. Now, luckily, there's a little bit of alliteration if you're trying to remember parameter and statistic. Population goes with parameter and sample statistic. Okay? It's a population parameter or a sample statistic. So we can look through each of these. In the United States, a survey of about 9,400 individuals aged 15 and over found that such individuals spent on average 5.19 hours per day engaged in leisure or sport. Is that a population parameter or a sample statistic? Why?
Because
they surveyed a sample. It is a subset of the population. Okay? They surveyed a sample of people. There's probably more than 9,400 people over the age of 15. Okay? So that is a sample statistic. Okay? The freshman class at a university has an average SAT math score of 514. We want to think about what is the population, and do we have a parameter or do we have a statistic? What do we think? It's the whole freshman class. Our population is the freshman class. Okay? And number one, our population was individuals age 15 and over. Question two, our population is the freshman class. And since the information gained is based on the entirety of the freshman class, it is a population parameter. Number three. What do you think? Parameter or statistic? Why do we say statistic?
Because they're not checking every test.
A random check of several hundred. Random check. Several hundred. It's a survey. Last year, a small company spent a total of $5.1 million on employee salaries. Population or parameter? Population. Total. What about number 5? Say that one more time. Why do you say that? We got a survey. Survey gives us a statistic. Okay? So, population parameters, survey statistics. All right? Now, there's two main branches of statistics, okay? And it all comes down to what do you do with the statistics? What do you do with the data or the information that's gathered? So the first part that we're going to spend most of our time with is the descriptive branch. The descriptive branch just describes. The branch of statistics that involves organization, summarization, and display of data. We are looking for trends. That's what the descriptive thing is looking at. The descriptive branch is. It's looking for trends or patterns in the data. Okay? It just is merely to describe. And then we have inferential statistics, which is to make an inference or a guess or a prediction about something. So the branch of statistics that involves using a sample to draw conclusions about a population. Usually using inferential statistics to kind of make a decision about something that should or should not be done. And we'll cover more of this later, but a basic tool in the study of inferential statistics is probability. So we'll be using statistics and probability models to come up with decisions and determinations based on the data. So for each of these studies, we want to identify the population in the sample, and then determine which part of the study represents the descriptive branch of statistics, and then think about what conclusions can be drawn from the study using the inferential statistics. Now, this part, answers may vary. answers may vary. So you're going to have to think critically about the information and maybe draw in on outside or prior knowledge to make an inference about the information that's being, which is something that you should, or a skill that you should learn and develop as you become a functioning adult. Hearing news stories and reading articles and listening to people talk and tell you things, you need to be able to infer based on that information. So with number one, we have a study of 1,502 U.S. adults found that 18% of adults from households earning less than $30,000 do not use the internet, as shown in the figure below. So we have the full figure there. Okay? What is our population? What is our population? I'm going to go broader. U.S. adults. U.S. adults. It's our population. Okay. What is our sample? That's one of the responses, not necessarily the sample. So you notice our responses are different income levels, right? Those are the different responses of the survey, of the sample. Our sample is 1502 adult survey. Okay. So now we want to look at what part is the descriptive. So looking at that presentation, what is being described? Okay. So households earning less than $30,000 annually. What about them? They don't use the internet. Okay. How much of those households? 8. That entire phrase is the descriptive. From there to there. It's the information that is describing the sample or the population. Okay? That is the descriptive part. But it doesn't just have to be the phrase. Descriptive distance. Okay? Doesn't just have to be the phrase, it's also the diagram. All that phrase is it took one part of the diagram and wrote it out in the sentence. But we could write an additional phrase and say, well, 7% of households earning between $30,000 and $50,000 don't use the internet. 3% of households between $50,000 and $75,000 don't use the internet. 2% of households earning $75,000 or more don't use the internet. So the diagram is also part of the descriptive branch. Now this is the part where some answers will vary. What inferences can we make based off of that data? You draw, given that information. Look at the trends, patterns, behaviors.
The more they,
Okay. The more they earn, the more they're on the internet. What else? gap between the 30 and the next group, 18% versus 7%.
The house incomes that make less than $30,000.
Think you're on the right track, but think about it. They don't use it at all. It's not amount of usage. It's at all. Do not use the internet. U.S. adults who do not use the internet at all. 18% if you're earning less than $30,000 a year, and then a significant drop-off of students not, or of adults not using it as the income goes up. Any other ideas of what that might imply?
Maybe that
Might include homeless people.
like
Internet might not be affordable for families making less than $30,000 a year, or is considered a luxury. For you, it may be considered a necessity. You need it to do your homework. But for those families, it might be a luxury. Something they either choose not to spend money on because they'd rather, have food that night, or something they simply can't afford. Okay? And so that's where this inferential statistics comes in, is making determinations. Okay, well, we have 18% of the population, in this subset, not able to access something that most of us think is kind of necessary for day-to-day life. And then you can use that to make decisions and determine policies and yada, yada, yada. Try and get people to do stuff. So a study of 1,000 U.S. 401k retirement plan participants, okay, so people that have a 401k retirement plan, found the percentage who do not know how many years their retirement savings might last is 32%. The 32% of 401k participants do not know how many years they will get out of their retirement savings. What's our population? U.S. 401k retirement plan participants. That's our population. And our sample. 1,000 of the 401k retirement plan participants. That is our sample. Okay. The descriptive branch of statistics is represented by what? How many of them? 32%. So the descriptive part is that 32% of plan holders do not know how many years their savings will last. Do not know how many years. And then, 32%, that's a decently high number. That's a third of the population. What inferences could we make given that information? It is less than half. Think about the information that's given. We're told a third of people with a retirement plan do not know how long their plan will last. Infer something on that.
Maybe they're spending.
Okay, so uncertainty in expenditures. Bills are going up. Prices are going up. Okay. Taxes are changing. saving too late. All of these are good. I mean, it's making a judgment based on the information that's given. Pretty hard to predict how much money you're going to need when inflation is consistently changing. When inflation is going up at different rates, the cost of goods is changing on, it seems like, a near day-to-day basis. It's hard to make a prediction. Okay? So you can make an inference that there's a lot of uncertainty. It's hard for people to predict how much money they're going to need and how long that money will last. Maybe they know how much money they'll have. They know, okay, I'm going to have $2 million for retirement. Well, how long is that going to last? Well, if gas prices keep going up the way they're going to go, maybe not as long as you would like. Okay? So it's hard to make a determination there. Study of 513 respondents to an internet-wide survey found that 97% of respondents said that music is important to them, and 83% of respondents said they are actively looking for new music. Population. Everyone on the internet. All internet users. Sample. 513 people. Descriptive. Both parts. 97% said that music is important to them, and 83% said they are actively looking for new music. Make an inference.
Most people that use the internet that consistently
Expand on that a little bit. Most people that use the internet are looking for new music.
Maybe the 14% like music, but they don't want to listen to new music.
Oh, that's good. A lot of internet users, 97%, find music to be important to them. So, almost all internet users, music is very important to them. And a still very significant number of them are actively looking for new music. Would it be fair to say they're probably using the internet to look for new music? Yeah. Pretty reasonable inference. Okay. So using data, using information to draw conclusions, make inferences. And that is it for